f at endpoints. And which one is the largest one? This is the largest one. So 17 is the absolute maximum. And the minus 3 is absolute minimum. By extreme value theorem and the Fermat theorem. The Fermat theorem. 定理的 Mandarin. Okay, sometimes we use this notation to indicate that the maximum of this function on this set. In mathematical programming, we call this function the objective function, and the set is the set of all admissible solutions. And the 17 equals f at 4. So this one is the optimal solution. Also, 2 is an optimal solution to this problem. 4 is an optimal solution for this problem. Or programming. Sometimes, if this is the revenue, or suppose f is profit function, we hope maximize our profit. So objective function, and this number make this value a maximum. So this number is also called the argument, or an optimal solution to this programming. Suppose f is the cost. Of course, we want to minimize our cost. Okay, cost. So a number from here which minimizes this objective function is called an optimal solution to this programming, or the mathematical programming. If this function is linear, then this is a linear programming. But now the function f is a polynomial function of degree 3. This is not a linear function. 有时候我们会把这个最大值跟最小值用这样表示，这样就相当于是一个数学规划问题，就是最佳化问题 （optimal problem）。最佳化问题。如果这个表示我们的利润是越大越好，当然要使这个赚的钱越多越好，所以考虑最大值。从这里面挑的一个数会使它变成最大值，这个东西就叫做这个最佳化问题的一个最佳解。那么这个值就叫做它的目标值。如果 F 代表成本，你要买东西，希望花的钱越少越好，这个是成本的话，那希望成本越少越好。于是对于这样的一个数学规划问题呢，会使它达到最小值的那个点，就称为是这个数学规划的一个最佳解啊。而这个值就是这个目标函数的一个值啊。而如果这个函数是一次函数，是线性的，这种数学规划就叫做线性规划，就叫线性规划。在高中有学过两个变数的线性规划。In high school or senior high school, you have learned a linear programming of two variables. I mean, an objective function looks like, for example, x plus y. And the admissible set maybe looks like this. You want to find an optimal solution to this problem or this problem. Usually, the extreme values occurs in these extreme points, at the extreme points. This is called linear programming. But usually, calculus deal with nonlinear. Okay, A, use a calculator with skip or computer to estimate the absolute maximum minimum. B, use calculus, yes. That is what we will do. Use calculus to find the exact minimum and maximum values. Again, this function is continuous everywhere. In particular, it is continuous on this closed and bounded interval. Now we apply the closed interval method. First, find the derivative of f. This is 1 minus 2 cosine x. Because the derivative of sine is cosine. I hope you still remember this. X, f prime of x, and f of x. From 0 to 2 pi. And the points are 0 and the 2 pi. The critical numbers, okay, minus 2 cosine x minus 1/2. If f prime is 0, then cosine x equals 1/2 by the definition or equivalent. An equivalence statement of cosine. If this is the unit circle, in order to cosine equals 1/2, and x between 0 and 2 pi. This is a solution, and this is a solution. Here, pi third, pi over 3. This is 5 pi over 3. And the cosine pi over 3 is 1/2. Sine will be square root of 3 over 2. And the coordinates of this point is, again, 1/2 minus square root of 3 over 2. This is sine pi over 3, and this is sine 5 pi over 3. So if this is 0, then under this condition, x equal pi third or 5 pi over 3, okay. This is pi, equivalently 180 degrees. This is 60 degrees. 3 pi, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 means 2 pi. Okay, at 0, sine 0 is 0. And x is 0, so this is 0, boundary point. And 2 pi, sine 2 pi is 0. So this is 2 pi. Here, the derivative is 0, the derivative is 0. Okay. If x between 0 and pi over 3, then cosine is greater than 1/2. This is positive, negative, so this is negative. If cosine between pi over 3 and 5 pi over 3, then cosine is less than 1/2. Less than 1/2, so this negative and negative is positive. Finally, on this interval, if x is greater than 5 pi over 3, then cosine is greater than 1/2. Positive, negative is negative. So the critical numbers of this function on this set are pi over 3 and 5 pi over 3. Okay. At pi over 3, we have pi over 3 minus 2 times sine pi over 3 is okay. Here the value is 5 pi over 3 plus, because minus and the minus is plus. Okay, we have 4 values. 2 values of this function at critical numbers, and 2 of them are the values of the function at endpoints. Which one is the largest? Which one is the smallest? Take a short break, we will find it out.